So in this video, we will be discussing the centroids by integration. Okay, so particularly centroids of plane areas with rectangular coordinates. So when we say centroids, so centroids may be imagined as the geometric center, okay, of an area, okay, or a volume. So when we say geometric center, so this is the location, okay, for which we can concentrate all the mass of the area. Okay, so sometimes the centroid also, this is the location of the center of mass or the center of gravity of a geometric figure. So say for example, we have simple symmetrical areas like a rectangle. Okay, so say for example a rectangle. So a rectangle is a very simple geometric shape. Okay, so its centroid will be a point located at the center. Okay, so where the location of that is one half of the length, okay, and one half of the width. Okay, so say for example this is our width, so one half of the width. Okay, so that is the location of the centroid. Okay, so for symmetrical and regular shaped areas, so the centroid can be easily located. Okay, so but what if we have irregular areas? Okay, so for irregular areas, the centroid by locating the centroid by integration is very useful. Okay, so the concept of the centroid by integration is just locating the center, okay, of an area. Okay, so say for example we have an area bounded in the first quadrant. Okay, so for example we have this area. Okay, so this area is not symmetrical horizontally or vertically, so there's no symmetry, but using integration, so we can still locate its centroid, say for example C. Okay, so with coordinates, so let's say the coordinates of the centroid is x bar and y bar. Okay, so the area by integration, we will solve separately for the x coordinate and y coordinate of the centroid. So it's called x bar and y bar. So for the x bar, so all we need to do is multiply the area and the x bar. That is equal to the integral of xc differential area. Okay, and for y bar, so ay bar is equal to the integral of yc differential area. Okay, so the differential area dA is the usual term, okay, for the usual integrand, okay, in determining the area of a curve, while the xc and the yc will depend upon the strip that we are going to use. So say for example for our area, we will be using a vertical strip. Okay, so say for example that is our curve, this is x and this is y. So when using a vertical strip, okay, so we will locate the centroid of the strip. Sorry, locate the centroid of the strip. Okay, so the centroid of the strip, so that now will correspond to xc and yc. Okay, so again, when using a vertical strip, then its centroid must be in here. Okay, so in this point, so let's make the point larger. So in that point, oops, so let's call that c. Okay, so its centroid will be at xc and this is yc. Okay, so based on the that what do you call that, based on that figure, then xc will correspond to x, okay, and then yc will correspond to 1/2 of y. So since this length is y, okay, so therefore yc is 1/2 of y. Okay, so again, that will depend upon the figure, but basically, again, all we need to do is locate the centroid of the strip, okay, for xc and yc. Okay, so obviously for us to solve for the centroid, so first we must solve for the area, okay, and then perform this integration. Okay, so the x c y c and then the dA actually is the same differential area that we use to solve for the actual area of the curve. Okay, so to understand that further, so let's have some examples. Okay, so for our first example, so find the centroid of the area in the first quadrant bounded by the curve y is equal to 4 minus x squared. And here we can solve it in two ways. Okay, so to start, so first, to solve for the centroid of an area, first we will solve for the area of the curve. And to solve for the area of the curve, first we must graph the curve so that we would know what strip are we going to use. Okay, so solution. So let's first take a look at the curve. This is y is equal to 4 minus x squared. So this, I think, is a parabola. Okay, so this is a parabola opening downwards. Okay, so if we factor out negative 1 in the right side, so y is equal to negative x squared minus 4. Sorry, we must first transpose 4 on the other side, so we have y minus 4 is equal to negative x squared. Okay, so this is parabola. So opening downwards. Okay, so with vertex at x, so our h is 0, and then our k is 4. Okay, so therefore this should look like this. something like that. So this is x, and then this is y, and then the coordinates here is we have 0, 4. So here we can solve at y is equal to 0, then 4 minus x squared is equal to 0, then x is equal to square root of 4, then that must be positive and negative 2. So we have positive 2, 0 in here, and then negative 2, 0 there. Okay, so here we are only concerned with the area at the area in the first quadrant. Okay, so we are concerned with this area. So in solving for the area, so we can use the horizontal or a vertical strip, but first let us use a vertical strip. Okay, so therefore we will be using dx, and then the length of the strip is y. Okay, so area therefore is equal to the integral of y dx from x is equal to 0 to x is equal to 2. Okay, so from x is equal to 0 to x is equal to 2 only, because we are only concerned with the first quadrant. So from 0 to 2. Okay, so since y is equal to 4 minus x squared, then our area is equal to integral of 4 minus x squared dx from 0 to 2. So integrating, so this will become integral of 4 dx is 4x, integral of x squared is 1/3 x cubed. Okay, from 0 to 2. Okay, so substituting the limits, so we will have 4 times 2 minus 1/3 times 2 cube minus, substituting the lower limit, 4 times 0 minus 1/3 times 0 cube. Okay, so we will now have an area of, so using our calculator, so it is 4 times 2 minus 2 cube over 3. So our area is 16 over 3. Okay, so now that we have the area, then we can now proceed with the coordinates of the centroid. So again, we will be using the formulas. A x bar is equal to integral of xc differential area, and a y bar is equal to the integral of yc differential area. Okay, so let's first solve for x bar. So again, xc and yc, those are the coordinates of the centroid of the strip. Okay, so this, so if that is our c, then our xc, okay, will correspond to x. So therefore xc will correspond to x, and then yc will correspond to 1/2 of the length of the strip. So our yc is 1/2 of y. Okay, so let's use those two. So ax bar is equal to the integral of xc differential area. So xc is, again, xc is x, because this is x, right? Okay, and then that's the coordinates, that's the x coordinate of the centroid of the strip. So x, and then differential area, so all we need to do is copy this differential area that we used earlier. So differential area is y dx. Okay, so since we are concerned with the centroid at the first quadrant, or area at the first quadrant, so from x is equal to 0 to x is equal to 2. So from 0 to 2. Okay, so next is integrate. So we have here y, we have a variable y, and we will have to integrate with respect to x. So therefore we will express y in terms of x like we did here. So therefore our y is equal to 4 minus x squared. So this will become integral of x, y is 4 minus x squared, okay, dx from 0 to 2. So distributing, so this will become 4x minus x cubed dx, okay, from 0 to 2. Then integrating, so the integral of 4x dx, so that is 4x squared over 2, or that is 2x squared, minus integral of x cubed dx, so that is x to the 4th over 4, so 1/4 x to the power of 4 from 0 to 2. Substituting the limits, so we will have 2 times 2 squared minus 1/4 times 2 raised to the power of 4 minus substituting 0, so this will become obviously 0, so 2 times 0 squared minus 1/4 times 0 squared. Okay, so using your calculators or not, so this will be 2 times 4, 8 minus 16 over 4. Okay, so let's check. So 2 times 2 squared minus 2 raised to the power of 4 over 4. So the ax bar is equal to 4. Okay, so that is ax bar, right? So ax, so from here again, ax bar is equal to 4. So since we are solving for x bar, then we divide both sides by the area. So x bar is equal to 4 over, area is 16 over 3. So 4 divided by 16 over 3. So that is 3 over 4. Okay, so that is the x coordinate of the centroid. Okay, so for the y bar, or the y coordinate, so we will be using this formula. So ay bar is equal to integral of yc differential area. So our yc from earlier, so our yc will correspond to 1/2 of y. Okay, so because that is the y coordinate of the centroid of the strip. So this will become integral of yc is 1/2 of y, and then differential area is just copy this y dx. So times y dx, since we are integrating in terms of with respect to x, therefore our limits must be from x is equal to 0 to x is equal to 2. So from 0 to 2. So integrating this, so this will become writing the 1/2 outside the integral sign. So 1/2 integral of y squared dx from 0 to 2. So this will become 1/2 integral of y squared. Okay, so since our y is equal to 4 minus x squared, then this will become 4 minus x squared squared dx from 0 to 2. Okay, so next, to integrate that, expand. So 1/2 integral of, so it will become 16 minus 8x squared plus x to the power of 4 dx, okay, from 0 to 2. And then integrate, so we will have 1/2 integral of 16 dx, so that is 16x minus integral of 8x squared, so that is 8x cubed over 3, so that is 8 over 3x cubed plus x to the 4th integral of x to the 4th dx, so that is 1/5 x to the power of 5 from 0 to 2. So substituting the limits, so we will have 1/2, substituting the upper limit, so 16 times 2 minus 8 over 3 times 2 cubed plus 1 over 5 2 raised to the power of 5 minus, if we substitute 0 in each term, so it will become 0. Then ay bar therefore is equal to, so using your calculators, so we'll have 16 times 2 minus 8 over 3 times 2 cubed plus 1/5 times 2 raised to the power of 5. Okay, times 1/2. So we will get 128 over we will get 128 over 15. Okay. Okay. So since we are looking for y bar only, so we will divide 128 over 15 by the area. So our area from earlier again is 16 over 3. So y bar therefore is equal to 128 over 15 divided by 16 over 3. So the y coordinate is 8 over 5. Okay, so therefore for our final answer, okay, centroid is located at, x bar is 3/4 and then y bar is 8 over 5. Okay, so those are the coordinates of the centroids, okay, of the area of that curve in the first quadrant. So we said earlier that we can solve it in two ways. Okay, so we can solve it in two ways by using a horizontal and a vertical strip. So our first method was using a vertical strip, then we can also solve it using a horizontal strip. Okay, so I think that will be your homework, okay, your assignment. So you try using a horizontal strip. So if you use a horizontal strip, Okay, so when using a horizontal strip, so then your area will be equal to the integral of, so since for horizontal strip we now have dy, and then our length of the strip is x, so therefore the area is x dy. Okay, so once you solve for the area, so you can now solve for x bar and y bar, okay, by using xc and yc as the centroids of the strip. Okay, so the yc so will correspond to y, so here is the centroid of the strip, so yc will correspond to y, while xc will correspond to 1/2 of x. Okay, so you try that on your own and see if you arrive with the same answer. Okay, so that's it. So basically all you need to remember is these formulas, so two formulas. Okay, and you have to first find the area of the curve, okay, and then determine the appropriate xc and yc. Okay, so again, xc and yc are the coordinates of the centroid of the strip. Okay.